We demonstrate that people can use the spatial cues available in virtual reality to help them effectively remember and recall scholarly articles. We used a virtual coffee shop and asked participants to remember 4 abstracts from scientific publications, and we termed this method a virtual reality memory palace variant.
Position is believed to be the most precise encoding channel, but our perception and memory of it can still be biased. Past work has shown that the vertical position of bars in a bar chart is recalled in a biased manner, illustrating both an underestimation and overestimation bias of position. Here we find that the aspect ratios of the bar marks can cause this position bias, specifically resulting in overestimation for bars with wide ratios and underestimation for bars with tall ratios.
While meetings are an essential part of everyday business life, most calendar visualizations are not designed for retrospection. We present a tool consisting of 4 coordinated views that integrate into the user's daily workflow and are designed to promote self-awareness about past scheduling decisions. We discuss the insights gained from an internal user study and from a field deployment. We also discuss how we strongly inherit from the principles of personal visual analytics despite targeting a professional environment.
With the proliferation of AutoML systems, it's now easier than ever for non-experts to create and deploy end-to-end machine learning pipelines. These systems explore the model search space and optimize hyperparameters in order to solve a particular task. We propose Pipeline Profiler, a tool that enables the exploration and comparison of machine learning pipelines produced by multiple AutoML systems. By analyzing these pipelines, we have the opportunity to better understand how AutoML systems work and obtain insights that can be used to improve them.
The classifier trained on the historical data may fail to classify the incoming data when the data distribution is changing. This phenomenon is called concept drift. To handle the concept drift, we developed Drift VIS, a visual analytics system to help the expert understand when, where, and why the drift happens, and update the model to improve performance.
The success of a convolutional neural network has been attracting many students and practitioners to learn the exciting technology. However, for beginners, the thinking model is not easy to understand. We introduced the Explainer, an interactive visualization tool to help beginners more easily learn about convolutional neural network. Using the Explainer, users can progressively explore the thinking model with real-life images in their browser, getting a comprehensive understanding of both high-level model structure and low-level underlying mathematical operations.
If machine learning were like education, we would like to test what concepts our student, the model, has learned. Has it learned the concept of object rotation? Does additional text help with object recognition? We need a methodology and platform for conducting such tests. In this paper, we present a novel visual analytics tool that enables hypothesis-based evaluation of machine learned models.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
In this talk, we introduce CallFlow, an interactive visual analysis tool that provides a high-level overview of performance profiles from large-scale scientific applications. CallFlow visualizes the flow of resource of a program execution as a Sankey diagram to detect performance bottlenecks in parallel codes. CallFlow simplifies these calling context trees based on semantic information by constructing supergraphs.
Spot SDC is a visualization system that helps researchers understand the resiliency of HPC computation kernels to silent error corruptions. It gives users multiple perspectives of details with different granularity about the impact of SDC on an application's output. It also provides novel insight into how silent error propagates through a program's execution.
As data is changing, our understanding of data should be updated correspondingly. Based on machine learning approaches, we formulate a drift-level index to monitor the evolution of multi-source data, which allows users to capture and reason significant changes from time series data. The proposed visual analytics system is called Concept Explorer. More details can be found in our talk.
Progressive visual analytics provides intermediate results in the middle of computation to address a long computational delay. However, such intermediate results are uncertain, so findings from these results can turn out to be incorrect for the entire data. In progressive visual analytics with safeguards, we suggest to risk the uncertainty, but we allow humans to leave safeguards every time they risk the uncertainty.
Data videos are quite popular nowadays. They usually show changes in the data. However, creating a data video requires multiple skills, and the process is usually laborious and iterative. Our approach focuses on automatic and interactive visual enhancement of important changes in time series data with data video.
Do these three essays construct their argumentation similarly? Where in this table of argumentation data from the previously seen texts can I find certain argumentation patterns? Do these three argument maps depict the same argument? We have developed a visual analysis system for argumentation in essays that can answer these questions at a glance. You want to know how it works? Come to my talk.
White space surfaces are a novel approach to convey depth in vessel visualizations. The core idea is to shift all additional depth cues away from geometry and to use the usually empty space between the vascular structures. This allows us to display functional parameters on the surface and supporting cues on the background. We will explain how to generate such surfaces and how to use them as a canvas to further enhance depth and shape perception.
Out-of-distribution samples refer to the test samples not well covered by the training data, like these black cats. They are misclassified with high confidence due to their black bodies. To explain why these samples are out of distribution, we developed OOD Analyzer, a visual analytics tool which provides an ensemble detection method and a grid-based visualization to detect and analyze out-of-distribution samples.
Suppose you want to see the overall structure of a new project repository. Using Git client tools, GitHub Network, or Git log command, it's quite burdensome to get overview and navigate data. We presented Githru as an interactive visual analytics system for the Git metadata to help users explore and understand the context of development history.
Linking and brushing is very useful for interactive visual data exploration. Data-driven brushing tools are getting popular recently and achieve good results, for example the Mahanoda-based brush and the CN-based brush. However, these brushing tools are optimized by the data from a large number of users, which are not suitable for everyone. In this paper,
All right, welcome everybody. I think we'll still have a few people joining over the course of the next couple of minutes. I definitely see a steady stream of people in the waiting room. So we should probably get going. We have a fairly packed schedule for the rest of the next couple of hours, which should be pretty fun, mostly built around a bunch of interactive exercises. So just encouragement, if there's anyone joining on the YouTube stream, most of what we're going to be doing in smaller groups and using breakout rooms. So I'll mention this a few times over the course of the next 15 minutes, but if you are watching on the YouTube stream and want to participate in the workshop, it's probably much better to go ahead and join via Zoom. And we'll keep the Zoom link in the bottom corner of the presentation pretty much all the way through. So I guess maybe quick introductions from all of us who are organizing really quickly. Cheryl, do you want to say a few words about you?
Okay. So I'm Charles Perin. I'm an assistant prof at the University of Victoria, and I'm looking forward to a very exciting workshop, and I want to keep it short because, as you said, we have a very packed schedule.
Great. Yeah, so I'm Wesley Willett. I'm associate prof at the University of Calgary. Have been teaching a number of courses very much in the space in the last few years, so I'm pretty excited to get to chat about this with all of you guys. And then Laura, who you'll see sort of filtering between my screen and her separate screen, is also an associate prof at Calgary. We're both on parental leave and we're juggling our little 3-month-old. So you'll probably see him in and out throughout the course of the workshop as well.
And hopefully not hear him too much.
So that's Reese. And then Sheila?
Yeah, I'm Sheila Carpendale. I'm a prof at Simon Fraser. And yes, I'm not going to take a lot of time with this introduction because we have lots of things we want to do. Thanks, Wes.
Awesome. So I'll give just a little bit of context up front. Again, reminder that if you're watching on the YouTube stream, this is going to be primarily an interactive workshop. So you won't see that much, especially after the first 30 minutes or so, unless you're actually joining via Zoom and getting into the breakout rooms. And again, going to be pretty interactive. So especially once we transition over to those interactive modes, we really appreciate if folks can be in Zoom, plan on participating actively, and that means camera and mic on, being a active part of your groups. So goal of the workshop is to try to stimulate some discussion around the impact of future technologies on visualization specifically. And really think about science fiction and design futurings as mechanisms for inspiring future viz research. A lot of this is driven by the impact of science fiction on computing broadly. There are a whole bunch of examples of this from basically the entire history of computing. In HCI in particular, you have lots of great examples of things like the use of gestural interfaces and transparent displays in Minority Report, which really directly inspired the last 20 years or so of work on gestural interfaces, including things like Connect or Magic Leap or Project Soli. You have more classic examples of things like the communicators in Star Trek, which have been cited as the very direct inspiration for the form of especially early flipped phones like the StarTAC. And you also have representations of augmented reality in film and TV and other forms of fiction that have served as a sort of direct inspiration for the kinds of augmented reality interfaces that you see proposed now for things like the HoloLens. Many of these are kind of visualization adjacent, but in practice, there hasn't been a whole lot of focus on doing this in viz research. Instead, what you have is a handful of papers in the HCI literature and books in the HCI literature. So things like Nation Tedroff and Christopher Nussel's Make It So, that are looking specifically to science fiction as inspiration for interaction design. And there's some work in the Chi and DISC communities that has specifically looked forward to pieces of science fiction as inspiration to try to identify things like negative dark patterns, or use them as inspiration for designing future systems that question issues of security or surveillance, et cetera. But again, within Viz, we don't have as many examples of that. And then finally, the other thing that I think is really interesting that's also a bit Viz adjacent is this practice of creating artifacts from the future. There's this really amazing column that ran for about 10 years, I think, in Wired magazine that was just built around lots and lots of examples of these ideas of future technologies that might live in our everyday lives, all sort of captured as either advertisements or little vignettes of people interacting with those technologies. And there's great work by folks like the Near Future Laboratory, who did this. This is, I think, about 5 years old now, but it did this future IKEA catalog proposing a whole bunch of possible future products. There's also corporate visioning videos, classic ones like the Apple Knowledge Navigator from the 80s, but also much more recent ones. I encourage folks at some point, if you haven't, to go back and look at the Microsoft Future Vision 2020 from 2013, which is an interesting contrast to, but also parallels with a lot of their technologies the last couple of years. And there's also some really nice, a bit more dystopian, a bit more critical examples of this kind of design featuring, particularly around interaction design, including things like Keiji Mitsuda's Hyperreality, which I also encourage folks to check out if you haven't looked at. So what we're really interested in doing is starting to think about the use of these kinds of futuring approaches for data visualization and encouraging some discussion around that. I think visualization poses some really unique challenges here. And there's only a few people who have really been exploring them. So folks like Dominicus Bauer have done a bit of work on this. Here's a nice couple of articles from a few years ago now, thinking about the future of Viz and augmented reality, and specifically focusing on how we might create augmented reality interfaces that maybe don't look just like AR representations of our traditional data visualization tools that we have now, but instead are more immersive and more integrated into our surrounding environments. And there's also been one really great workshop on this at Viz 6 years ago now. So at Viz in Paris, this visualization, that Viz had a Death of the Desktop session which was run by Petra, who I think is here, and Ivan Janssen, Pierre Josevich, and a few other folks, which was a really interesting chance to start to do a little bit of this kind of design featuring for VIS. And our goal this year was to try to channel some of that same energy, which I think in this case resulted in a number of publications. I had a few publications in the last few years that really drew specifically from artifacts that were created in the context of that workshop. And so our hope is to try to do something a bit similar here today. And what we really want to think about is how to address some of the specific challenges that you confront immediately when you start to think about using design featuring for visualization. So how do we think about designing for the specific contexts and users and technologies where visualization is important, but also how do we think about designing for future data? This is a problem that most design featuring doesn't necessarily need to confront, but with VIS, where the design of our artifacts is so tightly coupled to the data that we're trying to show, designing visualizations from the future without somehow simulating data from the future is actually quite challenging. And so we want to have a bit more of a discussion about that. The way that we're going to do that is to try to explore design featuring for VIS by designing and playtesting an imagination game specifically patterned after so again, we'll want to do this mostly in person, so a reminder to join Zoom if you're watching on YouTube. But we're going to do a visualization design and imagination game inspired by the Situation Lab's The Thing from the Future, which is a really interesting game that I've used a number of times in courses and folks will use in design workshops more generally, that's focused on imagining objects from the future and doing that by presenting a randomized set of prompts that people then sketch in a way that looks a bit like Pictionary. And we'll also draw a bit of inspiration from things like the IDEO method cards. I think our ultimate objective for the workshop is to start to think about how we might create a set of pedagogical tools or thinking games that we could use to encourage this kind of featuring in our classes and in other settings. So the plan for the day is that we'll, after this intro, switch over and give folks who submitted visualizations from the future to the workshop a chance to present their designs. That'll take about half an hour. After that, we'll break into groups and actually start to go through a design exercise where we try to create our own versions of the thing for the future that are tailored towards designing visualizations. We'll spend a bit of time doing that, then we'll mix the groups, do some play testing, and then use that to stimulate some discussion in the last hour or so. So in order to do that, what I wanted to do is just give you a little bit better sense of what the Situation Labs Think from the Future actually looks like as a game, so you all have a better idea of what we're going to be designing and what we're going to be playing. Their game is a really simple one. It's built around a set of 4 card decks, and each round of the game is pretty similar to something like Pictionary. Basically, there's a dealer who deals 1 card from each of their 4 decks. Their 4 decks happen to be themed around an arc, so basically a period of time going into the future, a terrain, which is more or less the context in which you're designing an object for, what the object is, and what the mood is. So for an example of this, there might be an arc that is an arc where society is undergoing growth, and you're looking at a period 30 years from now. You might be designing for education, and you might be designing a postcard where the mood is excitement. Then every player sketches a design based off of those 4 prompts, and afterwards players share their designs and they vote for the best one. So again, should be pretty similar to anyone who's played Pictionary or another kind of sketching game. Their particular decks are these arc, terrain, object, and mood. We're hopefully going to be going beyond that and creating our own decks that are really more VIS specific and help encourage the kinds of discussions and the kinds of designs that might be most interesting to folks who are doing visualization work. Just to give a little bit of a sense of what their decks look like, you can also download a print-to-play version of their original game if you're interested. I think we have a link to that somewhere. If you also just search for The Thing from the Future, you'll find it pretty quickly. To get a sense of what their decks look like, Their arcs range from collapse to transform to discipline, et cetera, and they have a pretty wide range of different timeframes, from a few years up to a generation or a millennium from now. Their terrain's also pretty broad, architecture to space to governance, et cetera, and a really wide range of objects as well, and a really wide range of moods. So what we wanted to do, just to give everyone a sense of how this works broadly, is to just practice by playing around together. So as part of this, everyone will want to try to make sure that you have something that you can sketch with. If you can't find it in the next minute or two, definitely try to find something in the next half hour. My recommendation is, if possible, to try to sketch with something that's fairly visible, so a really dark pen or a Sharpie, something that you'll actually be able to see if you are to, say, hold it up to the camera. Because we'll do a lot of sharing of these designs by just holding them up and sharing them. All right, so if you're not quite here yet, no worries, but we'll just spend a couple of minutes practicing this just to get everyone maybe a bit in the mood. So I'm going to play the dealer. I'll draw 3 random cards from our Think from the Future decks, and I want you to just spend about 2 minutes sketching. Let's think about specifically something that's in the visualization space that's inspired by those 4 cards. So our arc is transformation, a period of time that's about a generation. Our terrain is music. Our object is a prosthetic. And the mood is hilarity. So I'll set about a 2-minute timer. Try doing some sketching, and then we'll maybe see if there are a few folks who are interested in sharing their designs. We won't all share for this round. Right, about 45 more seconds. So quick sketching. All right, about 5, 4, 3, 2, 1. All right, we don't have a lot of time, but so maybe everyone who had a chance to sketch, maybe let's hold up all of our sketches and just get a sense of the diversity of what everyone created. Anyone in particular interested in sharing their super cool design?
I made a guy that the prosthetic legs jump to the beat of the music. If you visualize the music as like up and down beats, so he's jumping in a nightclub with his prosthetic legs to visualize the music.
I dig it. That's awesome. Any others really quick?
I have one that this is the music that I just played here on that. And this prosthetic helps me, a prosthetic is there so that I don't fall. And this prosthetic is there that the music doesn't drop and it just continues playing the song. And yeah, it's just whenever you play a song, then you have this prosthetic that keeps playing while you stop playing.
That's
My
awesome.
nose symbol only works if other people are wearing one as well.
I made a haptic mask that vibrates various environment sounds. I consider that music is organized sound. So it vibrates the sounds of the environment on the wearer's face for deaf people so that they get a sense of where they are in the world.
Awesome. So that's a super cool set of designs. I feel like we should keep moving and we won't share all of them, but you'll get a chance to do this a bunch more as soon as we jump into the breakout groups and start designing some of our own decks. I think you'll appreciate that these kinds of prompts can generate some pretty cool lines of thinking. And I'm really excited to think a bit more about how we can use this in a way that works well with designing for VIS specifically. I've used this a couple of times in HCI classes in the past. And what you get is really interesting designs, but designs that are sometimes are a little bit hard to fit into the specific application areas that we're really interested in researching. And so I'm excited to use this as a jumping off point to think about what the questions, what the prompts are that are really unique to VIS. So without any further ado, I think let's go ahead and start kicking into our actual session. So Charles will take over and lead our presentations of the visualizations from the future that everyone who submitted designs to the workshop sent in. And then after that, we'll be forming design session breakout groups. We're going to try to do groups of 4, and we'll see how many people we have in the Zoom at that point to decide how many groups we have. Again, if you're on YouTube and you're interested in participating, go ahead and try to join the group in the next half hour or so that we know how many people we have to assign to breakout rooms. So awesome. Thanks, everyone. And I'll stop sharing now and let Charles load up the next deck.
All right. Suppose you can all see my screen. And basically, how it's going to work is, so we have had quite a few very interesting submissions from people who submitted visualizations from the future, and we want it to be kind of very fast-paced to get inspiration for the activities to come. So what we'll do is that each submitters will have 2 minutes maximum. It can be shorter than that, but I will stop you at 2 minutes. I'll give you a 15 minutes warning when you're close to the 2 minutes. You have one image, and you try to talk about your submission, in particular talking about what the idea is about briefly, how you came up with this idea, what's your process, and what are alternative visualizations that you could imagine using this idea as a starting point, like in a different context, different data, different future, etc. And to remove some of the pressure, I will start with 2 that are actually from the organizer. So I will do the first one, then Wes will follow, and then it will keep going with the other submissions. And you should have an idea of when is your turn based on the slide deck I shared with you previously. All right, so I put a timer for myself to make sure I don't go over 2 minutes. Let's go. So here the idea is about seeing data visualization as artifacts that are part of our everyday environment. In this image here, we see parents that are chatting about their child's biometrics and in their living room. And around them, we have visualizations that are part of their daily environments, much like pictures in frames, where personal visualizations, they provide information at the right time, the right place for the right viewers. And the idea came up from having my first child. It was actually the first situation 4 years ago that my partner got interested in data ever and in visualization, because this was very personal and because it was useful to make sense of what was going on, because it was also reassuring to see how things were going, etc. And so often we had these conversations that required us to think back about things like sleep patterns and diaper changes and breastfeeding that we didn't really keep track of, but that would have been very nice to inform our conversation in our daily life. So I would think from my visualization lens about what kind of visualization would be useful for that, where it would show and how. So data has always been there and it will always be there in the future also. And so I hope that in this future, we'll make more meaningful use of this personal data in this everyday context. But for that, the visualizations would have to blend into our homes or offices or even outdoors and show up when we need them, for those who need them, or are allowed to see them also, so that we end up interacting with these without really thinking about it. They become part of our everyday life. All right, I'm done. And the next is Wesley.
Hopefully this video plays. Yeah, so the one that I had submitted is something that I actually submitted originally to that 2014 Death of the Desktop workshop. It is an artifact that I found really interesting because it's inspired a bunch of my thinking about specifically situated and embedded visualizations over the course of the last 5 years. This particular artifact was envisioning really small 1.5 centimeters across illuminated drones that could form dynamic visualizations in your surrounding environment and which could work as a sensor or as an input device, or could physically go out and manipulate the surrounding environment. And so in the process of this, we ended up having a bunch of discussions about how those kinds of small drone swarms could create visualizations by actually manipulating objects in your workplace or in your home environment, or could come around you to find wireframes of buildings. I think it was also interesting because it resulted in a bunch of discussions about some of the challenges associated with this technically, but also some of the ethical and political implications of these kinds of visualization technologies. So thinking about how this could be deployed in a military context, what the risks might be of having multiple people operating these sorts of systems side by side or in conflict with one another. And this is particularly interesting to me because these discussions led very directly to a couple of papers on situated and embedded visualization that we published at VIS in the last couple of years. And hopefully we'll have some similar outcomes from the discussions around this workshop. Thanks. I think that's it.
Cool. Mine is next, I think. My visualization is about visualizing patient health data, as I'm interested in health data. We know that patients often monitor their health and they collect health data, they share it with their healthcare provider when they go visit their doctor. And on the other hand, when we look at the doctors and healthcare provider, they also regularly order and bring medical tests that they want to discuss with the patient during a clinical visit. And it's really hard and time consuming to review all this data in a short clinical visit, which I'm sure you experience. It's like 5 or maybe 10, 15 minutes max. So our idea is to visualize this data on a shared surface to support both healthcare providers and patients so that they can present, collaboratively review, and analyze these patient medical information during a visit. And this idea actually came from a lot of the empirical studies that I conducted with my supervisor and other member of the lab when I was in Calgary during my PhD. And we wanted to understand the challenges that patients face when they collect and share their self-generated data with their healthcare provider. In addition to patient data, when I started my postdoc, I was very in direct contact with physicians, surgeons, and nurses. So I started observing how they're working and what are the challenges they're having. And one thing that was very prominent for me was when I saw that they face a lot of challenges when they want to discuss test results, medical decision, and educational materials with their patients in a short visit. So I started thinking about how can we help with designing visualization that can summarize both these sources of data and smoothing the communication between patients and healthcare providers. So my future vision is to have large shared displays in a clinic where both parties, healthcare providers and patient, can interact with health data. And maybe some of you've seen, like as Wes mentioned, movies that you see like a surgeon or a patient being surrounded with data in a space. So hopefully that would be our future. That's my vision. And in terms of alternative context, that was a question that was brought up. And I envision this visualization could be useful in any collaborative setting where two parties would like to discuss data and they each bring one data set. That's it.
My name is Jillian Orsano, and I'm a PhD candidate at the University of Illinois Chicago in the Electronic Visualization Lab. And my submission is called An Immersive Dialogue with Data. And it's about a scenario, say 10 years in the future, when researchers are using machine learning to try to understand how to improve crop yields given changes due to climate change. And I focused on how the large display wall and a smart assistant could help the two collaborators here engage in a dialogue with each other and a dialogue with their data by asking questions and then seeing views that are helpful get populated onto the large display wall. And this mock-up actually came from a real collaboration with researchers in biology. Years ago at the start of my graduate degree, we were thinking about how to use large displays to show their data. And when I generated this mock-up, the main question they had was, how would they actually arrive at this state on the display? Like what interactions would produce this for them? And I've come to realize that that's an incredibly difficult question and a question that might take 10 years for us to address. So I thought I'd submit it here. And if I were to think of this as a starting point, some of the questions that I would ask would be, here I'm thinking about two people in one room looking at their data. What would happen if we're thinking about 50 people spread out across a much larger area? Because that's a very different kind of problem, even if it's the same data and the same challenges. So that's my submission. Thanks.
Hi, I'm Sydney Pratt. I'm from the University of Calgary. I'm a PhD student. My idea was around social media. So in social media, there's a huge trend to follow people, whether or not you've ever met these people. They can be for different inspirations, different likes and all that. And then there's friends that you may know, but you never really get the chance to see. And after several conversations that I had with others, I realized that we could be walking past these people all the time and we don't know it. So the idea behind this visualization was probably like a wearable kind of garment, or even I tried to make it a little bit more sci-fi and had like augmented visual links as well, but to connect people who we pass every day on the street and link back to their kind of accounts and so like these people that we follow. And the idea behind it is kind of that I feel like a lot of these like even celebrities and people who have like these inspirational social media accounts, and that we kind of almost dehumanize them because they're on this we just look at their life through the social media lens. And this can kind of help make more real relationships and kind of remind people that these are real people at the end of the day who go about their life. How I imagine this in the future, or like other ways that this could inspire other visualizations, is I've been thinking particularly about how to like humanize data, and this could be done in other kind of connections, so like interests and things like that, not just relationships, but other interests. This could also be used for like other kind of information as well, maybe not social media, maybe it links professional or other kind of things like that. And yeah, that's my submission.
Hi, so I made this fake app called Coco, or Connected Companion, and it's a context-aware wearable that can detect when you've had alcohol or caffeine, or tell when you're stressed, as well as explore the relationship with your pet. So the notifications shown at the top, they appear when an event occurs, such as when you drink caffeine. And the idea is to make people aware of the substances that they're consuming or putting in their body, the effect that this can have on their health and well-being at the relevant moment. So visualizations across the app give you more context based on if you're in the living room and so you're drunk, the closest places for you to vomit, or if you're having a bad night's sleep, you can find out that maybe your cat was the reason that you woke up in the night. So my inspiration for this was, as part of my PhD, I've been looking at how people make sense of data from self-tracking devices and how this can be used for relationship change, behavior change, focusing on ethical questions around what we could or should track. Alternative ways to look at this kind of stuff could be through different visualizations, such as comparing the data of different people in the household and see how that overlays. Or it could also be like the Near Future Lab does, like a booklet that has the user manual of the wearable and shows how it tracks different things. But it does lead nicely into another project we did about what if third parties had access to our health and well-being data. So this was looking at something beyond healthcare. So we decided to look at the streaming service Netflix and say what would happen if they had our data. So stuff like tracking our heart rate while watching a trailer or a film and using that to recommend more content, or seeing where people clicked when they were drunk versus when they were stressed. And it might show like if they watch certain shows. The idea behind all of this was basically to explore people's reactions to this kind of data and show implications for decisions when creating these systems and the impact that that can have on people's day-to-day life. So yeah, that's pretty much everything summed up.
And I had pinged Curtis. I don't see him in the room anywhere. So maybe we should go ahead and skip this and we'll see if he joins before the end of the fast forwards.
Hi, my name's Jimmy, and Immersive Forest uses AR glasses and built-in cameras and sensors to detect and identify plants and then visualize information from each specific plant onto its trunk. So it shows data such as name, its age, its health, and possibly an easy diagnose of why the tree's health is bad to the user. And my process of coming up with this system is, well, I've been taking more walks recently due to the pandemic, and I find myself often in forests and just looking at trees, wondering how long they've been there. So it'll be really cool to have a easy way of knowing how old the trees are and possibly what kind of health they are in. And I can imagine that this kind of visualization is very useful for other things other than trees. Like it's possible to use it on people too, like see their health and see their status or things like that. Or it's basically suitable for, I guess, things you see in your everyday life. Thanks.
Hi, my name is Alec, and I'm a software engineer in New York and also on the part-time faculty of the data visualization program at Parsons School of Design. My futuristic viz is a prototype of an app that a person could use to conduct ranked choice voting, which is going to be in effect in New York starting next year. Ranked choice voting, as you may know, means that you don't just pick one candidate, you can pick you can rank all of the candidates who are running in your order of preference. And so just presenting the options that a person can vote for and displaying them back to make clear what the user has ranked is a visualization challenge. I think it's also exciting to use visualization as part of data collection and not just data display or presentation. So I imagined here that that the user would see the list of candidates and be able to physically drag them on a screen into place, as opposed to the sort of conventional way of voting in New York, which is to fill in a bubble on a piece of paper. Now that becomes a lot more complicated when you have to rank, say 8 candidates for 8 different positions in order of preference. And the mock-ups of ballots that have been presented for use in New York City next year are, I think, at best a little bit challenging for people to use. And so there's no reason that in the future we couldn't use technology and visualization to make this more seamless and intuitive process, integrated into the places and spaces where people are already spending time, like on their phone or like the interactive kiosks you see in buses or subways. I think other ways that this could be extended would involve nudging people with data on how many others around them have voted, or whether the people around them have voted for or have ranked all 8 candidates or have only ranked 4 of them, for example, because we want, while keeping people's votes private, to nudge them on other people's participation as well. Thanks.
Hi, my name is Catherine Blair. I'm a PhD student at the University of Calgary in computational media design. So this concept was about looking at the links between people's data. Sydney is talking about like social links, and I'm thinking about visualizing like how are our data sets connected, because in my PhD research, I'm looking at how can I engage members of the public with thinking about algorithmic decision-making systems and like the impact of those on our society. So looking at that in the context of visualization, thinking about how do we, like, could we visualize the web of the ways that people are interconnected? And so that is kind of the main concept of this. The mechanism for this, I was imagining like fans with smoke, which is fairly whimsical. But then other ways that this could be maybe extended could be to visualize other types of things. It'd also be really interesting if knowing about the connections between different data sets and how our data is connected to each other could help us understand each other better, or maybe interact with each other better, or potentially understand how information about us is used and advocate for ourselves. Yeah, so I think that's all I have to say about the first one. And then the second one that I submitted is called WEFT. And this one is kind of like a tapestry of data. So the tendril concept was more about how are our data sets interconnected. And then this WEFT was more about what information is gathered about us and then used by, institutions, companies like Netflix, or companies like health insurance companies, or the government, to make decisions about what services we receive or how they provide information to us. And so the concept for this was basically like we all have a tapestry that is continuously woven of where all our data is coming from, and how it kind of comes together to form basically like the working picture of us that institutions use to interact with us. And I ended up getting really interested or thinking a lot about like a picture of Dorian Gray kind of metaphor, where the tapestry is becoming like the real you, and then you are the person like you actually experience the impacts, but the tapestry is sort of the important, like the actual active item or the sort of real thing. And yeah, and then I was also kind of thinking that this would be made by like a Jacquard loom in everybody's house, and so it would like keep printing out and go along their wall. But again, the technological envisionings for both of these were kind of whimsical rather than something I expect we would all have tomorrow. Yeah, I don't know if that covers things.
For the last one, yes. Excellent. Okay, let me go back to the agenda that we had. Thanks a lot, everyone. Actually, I didn't have to stop anyone. I think one went over 5 seconds. So that was very good timing. Excellent job. We are almost on time. We are on time. Incredible. So the next thing we are going to do is actually a first session of breakout activity. And what we want to do in this first activity is to identify what we call factors of visualizations from the future and start creating cards so that after the break, we can actually play a game of cards. So in this first part, we create things, and in the second part, we'll get to play with them. What we want to do is so identify factors that would make good decks of cards, like we played around with the things from the future at the beginning, and you had these 4 different factors, right? Or decks of cards, different dimensions that you would pick from. And so we want to create these decks based on the future visualizations that people have presented. I have shared the slide decks both on the Zoom chat and on Discord. So you can have a look at these things for inspiration, but also other people have actually already posted things in the Discord channel about other examples you can look for on the web. So don't hesitate to just look at ideas around and try to identify things that you would call factors. It's very not well defined, and it's on purpose. It is pretty flexible here. And then once you have identified one factor, we want you to create at least 4 examples of cards that would be inside that deck. And I will go through an example in a sec. You can, as a group, create as many decks as you want, and we'll provide you with a template for that. So each group will have this kind of template. It's basically a Google slide deck. Each slide is one deck, and then you have different cards that you create to illustrate that are instances inside that deck, basically. It's pretty open-ended. You can sketch things, you can draw things, you can type in things, or you can paste pictures from the web, etc., change colors, whatever you want to do with that. Here is I will probably give you the example first. That's a very simple example. So here the deck would be, the dimension would be people. And here are some examples of what this could be. So if I were to draw a card from that deck, that could be an android or a couple or a child or a cat. And you can see different types of descriptions you could give, just so that people can get a sense when they pick that card, this card, what they are supposed to think about to design. And so going back to this slide, I think I talked about all of these things. What you will need to do is to Wes, maybe you want to jump in because you have created the groups in the meantime, right?
So yeah, so we had originally planned to just assign everyone to breakout groups. Because we aren't able to be the hosts, what we're going to do instead is our technician is going to create a set of 10 breakout groups. Those breakout groups will all have distinct names. And what we want people to try to do is to self-allocate to those groups so that each one has about 4 people. We also have created a folder with a set of slide decks, which I'll share in chat and Discord as well. What we want you to do is open the, okay, perfect, Charlotte's already done it. What you want to do is open the presentation that corresponds to your group number and use that as the place where you work to start creating your decks. Again, we're hoping that this is a kind of dynamic conversation within each one of the groups and that you're able to produce 3 or 4 decks during that time period, but also have some discussions about some of the interesting factors that go into visualization design and visualization futuring and what the best ways might be to inspire people to create interesting designs. Yeah, so Charlotte's sharing here. These are all of the groups, all of the slide decks for each one of the groups. Those are the group names, so alpha, beta, delta, gamma. And the breakout rooms will have those same titles. And we'll also do our best to get one of the organizers or somebody who's played the thing from the future into each of the groups. So anyone who has played it before, I know a number of the folks from Calgary have. Ideally, you'll end up in a group with some other folks who haven't played it before. So we have a little bit more distributed knowledge of how to actually play the game and what the game usually looks like.
And while we are in the breakout rooms, you can still communicate through Discord in particular for if you have any questions. So that's the kind of where all of us will still have access to that part. And in your breakout room, you will see somewhere at the top or at the bottom, I don't remember, the name of your group. And so based on this name of your group, you will know which slide deck you're supposed to be working on. You had a question, Lynn.
I did. Just remind me about how we know which of these groups we're supposed to be in.
So you're going to receive an invitation to join a group. I believe that's how it's going to work. Or you will select it. I don't know exactly how it's going to work from the tech side because we are not the ones controlling it. Can we get
select the breakout?
Okay.
At the bottom of Zoom, there's a button breakout session, and there's a couple of sessions, and you have to.
Taylor-Coyer flows is a turbulent fluid motion created in the gap between the two rotating cylinders. The traditional reason-based methods are only able to capture the small-scale coherent structure. The detection of the large structure depends on the 2D cross-section, which is not the true configuration. We adapt the feature level set methods and the density estimation to combine multiple attributes and use them as the filter to separate large and small-scale structure.
Confusion flow is an interactive visualization for the performance analysis of classification models. It introduces a novel temporal adaptation of the confusion matrix, which lets model developers compare the learning behavior of multiple classifiers over time. Find out more about confusion flow in our talk or in our TVCG paper.
How do you visualize the nanoscale, 1/1000th of a meter, for the public? As part of a Science Center exhibition, we developed an immersive environment that explains nanoconcepts by allowing users to explore nanoproperties. We reflect on how exploration, the confluence of explanatory and exploratory visualization, can be applied to visualization in public spaces.
Digital humanities present great opportunities for testing new visualization approaches and evaluation techniques. However, and given the diffuse character and novelty of the field, it may also be intimidating for novel and senior researchers willing to get started in the discipline. In this paper, we propose a data-driven analysis of visualization for the digital humanities to identify key themes, authors, and relevant publications. So if you want to know more, please read our paper.
A testing environment for continuous color maps. Many other fields in the computer science do it, we should do it too. With our work, we introduce the approach of using test functions as a standard evaluation method. We present a test suite for continuous color maps implemented in the CCC tool. Adapt the task to your requirements at the interactive testing section and observe them at the testing evaluation section.
In our current work, we visually compare two cohorts of segmented and classified tissue images, originated from single-cell omics data. To that end, we developed data-driven and interactive workflow, implemented in a multi-linked view system. Finally, we show the effectiveness of our workflow through specific case studies.
Scatter plots and parallel coordinates are widely used for visualizing multivariate discrete data. However, for multivariate continuous data, the continuous scatter plots and continuous parallel coordinates are more suitable. In this work, we extend them to uncertain data. Additionally, we also extend fibers to uncertain data. If you are interested, come to our presentation.
We present the first generic design space and library for visual piling. Inspired by physically piling paper documents, visual piling describes an interface for spatial organization of visual artifacts into piles of partially overlapping items. Piling affords interactive grouping, arrangement, previewing, browsing, and aggregation to reduce the complexity and support comparison of large collections of small multiples.
Deep neural networks are vulnerable to maliciously generated adversarial examples. This brings high risk in applying these networks to safety-critical applications. We developed a visual analytics approach to explain the root cause of such wrong predictions. Our contribution contains a constrained path extraction method, a river-based visualization, and a contribution analysis method.
CMED is a visual analytics framework for exploring medical image data annotations acquired from crowdsourcing. CMED can be used to visualize, classify, and filter crowdsourced clinical data based on a number of different metrics such as detection rate, logged events, and clustering of the annotations. CMED provides several interactive linked visualization components to analyze the crowd annotation results for a particular video and the associated workers.
Several recent studies advocated the use of non-parametric density models for the improved characterization of data uncertainty. The non-parametric models, however, present the challenges such as increased memory and computational requirements. In this work, we propose an efficient non-parametric framework for volume rendering in the context of uncertain data and show their effectiveness in classifications via comparisons with the other statistical models. Morse complexes have shown a great utility in understanding the topology of complex scientific datasets. The noise in the scalar field, however, can significantly distort the Morse complex topology. Hence, we study the extraction of Morse complexes for ensembles of noisy scalar fields through their uncertainty visualization using our proposed statistical summary maps.
Asteroids have always been and will always be a threat to life on Earth. Most likely, an asteroid will hit deep water, but what properties will actually lead to a threat like a tsunami? Ensemble simulations are a common tool to understand the effect of different parameters like the size of the asteroid. We propose an interactive visual approach to help analyzing deepwater asteroid impact simulation ensembles.
We present TransVis, a design study that is proposed to analyze and integrate close and distant reading of multiple translations. TransVis presents the overview of the collection to capture global patterns that is facilitated by the ADM-VIF matrix. TransVis integrates a detailed view to explore interesting path of alignments. We also propose the TLC view to examine and explore the terms of the user selected path to justify and reason the AD analysis.
We have seen many visualizations for tree data structures, but when showing changes in trees over time, some focus on displaying hierarchy, while others highlight their changes. With split streams, we combine two approaches and their individual benefits. We evaluated our method in a user study and consider it a general purpose method for the visualization of dynamic hierarchies. Our JavaScript library is openly available.
In this study, we designed a system named Causality Explorer to facilitate the causal analysis. Users can explore the causal graph to perceive the causality and its uncertainty, validate the causality with the raw data, and apply the confirmed causality to what-if analysis.
We asked participants to recreate bar graphs. When the bar was alone, we saw a different pattern of error than when the bar was presented with context in a stacked bar graph. We find that absolute error increased for higher bars when they were presented alone. We also found that there was a bias in the responses such that they were repulsed from an implicit 50% mark. We found a magic number, 10%, to predict error. Participants are usually within 10% of the height of the bar.
We demonstrate that people can use the spatial cues available in virtual reality to help them effectively remember and recall scholarly articles. We used a virtual coffee shop and asked participants to remember 4 abstracts from scientific publications, and we termed this method a virtual reality memory palace variant.
Position is believed to be the most precise encoding channel, but our perception and memory of it can still be biased. Past work has shown that the vertical position of bars in a bar chart is recalled in a biased manner. illustrating both an underestimation and overestimation bias of position. Here we find that the aspect ratios of the bar marks can cause this position bias, specifically resulting in overestimation for bars with wide ratios and underestimation for bars with tall ratios.
While meetings are an essential part of everyday business life, most calendar visualizations are not designed for retrospection. We present a tool consisting of 4 coordinated views that integrate into the user's daily workflow and are designed to promote self-awareness about past scheduling decisions. We discuss the insights gained from an internal user study and from a field deployment. We also discuss how we strongly inherit from the principles of personal visual analytics despite targeting a professional environment.
With the proliferation of AutoML systems, it's now easier than ever for non-experts to create and deploy end-to-end machine learning pipelines. These systems explore the model search space and optimize hyperparameters in order to solve a particular task. We propose Pipeline Profiler, a tool that enables the exploration and comparison of machine learning pipelines produced by multiple AutoML systems. By analyzing these pipelines, we have the opportunity to better understand how AutoML systems work and obtain insights that can be used to improve them.
The classifier trained on the historical data may fail to classify the incoming data when the data distribution is changing. This phenomenon is called concept drift. To handle the concept drift, we developed Drift VIS, a visual analytics system to help the expert understand when, where, and why the drift happens, and update the model to improve performance.
The success of a convolutional neural network has been attracting many students and practitioners to learn the exciting technology. However, for beginners, the CNN model is not easy to understand. We introduced the Explainer, an interactive visualization tool to help beginners more easily learn about convolutional neural networks. Using the Explainer, users can progressively explore the CNN model with real-life images in their browser, getting a comprehensive understanding of both high-level model structure and low-level underlying mathematical operations.
If machine learning were like education, we would like to test what concepts our student, the model, has learned. Has it learned the concept of object rotation? Does additional text help with object recognition? We need a methodology and platform for conducting such tests. In this paper, we present a novel visual analytics tool that enables hypothesis-based evaluation of machine learned models.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
In this talk, we introduce CallFlow, an interactive visual analysis tool that provides a high-level overview of performance profiles from large-scale scientific applications. CallFlow visualizes the flow of resource of a program execution as a Sankey diagram to detect performance bottlenecks in parallel codes. CallFlow simplifies these calling context trees based on semantic information by constructing supergraphs.
Spot SDC is a visualization system that helps researchers understand the resiliency of HPC computation kernels to silent error corruptions. It gives users multiple perspectives of details with different granularity about the impact of SDC on an application's output. It also provides novel insight into how silent error propagates through a program's execution.
As data is changing, our understanding of data should be updated correspondingly. Based on machine learning approaches, we formulate a drift-level index to monitor the evolution of multi-source data, which allows users to capture and reason significant changes from time series data. The proposed visual analytics system is called Concept Explorer. More details can be found in our talk.
Progressive visual analytics provides intermediate results in the middle of computation to address a long computational delay. However, such intermediate results are uncertain, so findings from these results can turn out to be incorrect for the entire data. In progressive visual analytics with safeguards, we suggest to risk the uncertainty, but we allow humans to leave safeguards every time they risk the uncertainty.
Data videos are quite popular nowadays. They usually show changes in the data. However, creating a data video requires multiple skills, and the process is usually laborious and iterative. Our approach focuses on automatic and interactive visual enhancement of important changes in time series data with data video.
Do these three essays construct their argumentation similarly? Where in this table of argumentation data from the previously seen texts can I find certain argumentation patterns? Do these three argument maps depict the same argument? We have developed a visual analysis system for argumentation in essays that can answer these questions at a glance. You want to know how it works? Come to my talk.
White space surfaces are a novel approach to convey depth in vessel visualizations. The core idea is to shift all additional depth cues away from geometry and to use the usually empty space between the vascular structures. This allows us to display functional parameters on the surface and supporting cues on the background. We will explain how to generate such surfaces and how to use them as a canvas to further enhance depth and shape perception.
Out-of-distribution samples refer to the test samples not well covered by the training data, like these black cats. They are misclassified with high confidence due to their black bodies. To explain why these samples are out of distribution, we developed OOD Analyzer, a visual analytics tool which provides an ensemble detection method and a grid-based visualization to detect and analyze out-of-distribution samples.
Suppose you want to see the overcoming structure of a new project repository. Using Git client tools, GitHub Network, or Git log command is quite burdensome to get overview and navigate data. We presented Gitthrough as an interactive visual analytics system for the Git metadata to help users explore and understand the context of development history.
Linking and brushing is very useful for interactive visual data exploration. Data-driven brushing tools are getting popular recently and achieve good results, for example the Mahanoda-based brush and the CN-based brush. However, these brushing tools are optimized by the data from a large number of users, which are not suitable for everyone. In this paper, we introduce an adaptive brush model which takes the user in a loop to improve the brushing accuracy.
When developing a deep learning model, people typically struggle to optimize hyperparameters that affecting the model performance. To relieve the pain of this manual trial process, AutoML has been developed as a solution. However, to maximize the potential of the AutoML, people should identify a good AutoML setting for their task. HyperTender helps to maximize the potential by visualizing AutoML algorithm behavior and guiding effective hyperparameters.
Imagine you have tons of text data to analyze. And you want to get an overview of your data, but traditional topping modeling techniques such as LDA are not working for you. Then, why don't you try Architext? We introduce a scalable and flexible way to interactively build hierarchical topics.
CarxS is an authoring system which enables rapid
again about 2 months ago because I wasn't moving around and I wanted more power and a wired internet and all of those kinds of things so that a lot of things got less flaky.
All right, are you ready to begin again? Probably. Okay, cool. So welcome everybody back, or if you're new, welcome. So we just got finished doing breakout sessions where everyone was in separate groups and developing and generating ideas for different decks. So now we are at the sort of 2 p.m. playtesting in mixed groups. Cheryl, can you go to the next slide? So now we're in the playtesting and refinement phase. So we came up with all of these interesting decks, but now we'd like to try them out. So what we've done is we've figured out an assignment of groups. So we've taken 2 people from, so we've taken the groups of 3 or 4, and we've taken 1 or 2 of the people from each group and combined them with the next group. So as Charlotte is showing you, we basically have, if you were in Wilco, you're now going to be joined with either 2 people from Alpha or 2 people from Luna. So we've done this group reassignment. And this is basically so that as you play test, you sort of see somebody else's deck and blend it with your deck and see how this exercise works out. You'll have about 20 minutes to play rounds using both teams' decks. So you don't have to use all of the decks. So each round you pick a dealer who chooses between 3 and 5 of the decks to draw from. And what you want to do is use a random number generator or a dice or whatever to randomly pick cards from those 3 to 5 decks. And then that becomes the prompt to do the drawing. What's really important is to try not to get too bogged down with the meta activity of like, we are designing a design tool, and focus just on the drawing piece of it. So keep it quick, just draw for 2 minutes, and then use 1 minute to vote or discuss the concepts. and see if you can play as many rounds as you can. And so this is the template we've generated for the playtest. Feel free to duplicate this and add more as you do more rounds. But this is basically so that with round run, you can use this to document, okay, we use this card from this deck, this card from this deck, and then as people generate things, you can take photos and post them and add them to the Google Slides. And so after those 20 minutes are up, we'll sort of stop and have that meta conversation to step back from the decks and discuss if it's working, or if not, why not. So feel free to take that time to update the decks or create new cards or create alternate versions of the decks based on your experience. Also feel free to tweak the gameplay mechanics. So if you find that you always need one of the decks, keep that as your consistent deck and then rotate in the other ones. Or if you want to like collaborate or do whatever you'd like to the gameplay mechanics, feel free to play with that as well. And then we'll do a second play test for another 10 minutes, once again, doing as many rounds as you can. And so the way we've got that set up is we have, you can keep going, Charles. We've got it set up, most of the organizers are trying to sort of spread out a little bit. I will still be sort of floating, so you can let me know in Discord or in Zoom if you need help from me, and I will drop into your room and see if I can help answer questions. That makes sense. Any questions before we get started?
Just wanted to add something, or perhaps correct you. Sorry, Laura. Okay. But you mentioned adding pictures to the slides. That's something you can do, but also feel free to just draw and show to the camera to your colleagues in the room, because it might take time to upload and thing. And so rather than documenting exactly what we do and storing, it's better to do several rounds, I think, and go, like, apply this process several times. And because we want to reflect on what it means to play that rather than what we generate from it.
Yeah. Hopefully that makes sense. So don't feel compelled to like add everything to the slides. You can also just show it on Zoom like that, if that's what makes the most sense. Excellent.
Okay, so I'm going off to the breakout room. See you guys later.
And if we missed anyone in this breakout room assignment, hopefully Laura and her tech can help get you assigned into one that makes sense. Or if for some reason you're joining but weren't in one of the previous groups, etc. If for whatever reason we got it wrong, Laura and her tech will stay behind and hopefully get you sorted out.
I will stop sharing because I'm going to join my room, but there is a link to the spreadsheet on Discord. I'm putting it on Slack, on Zoom now too as well, and then I will disappear. Oh, I cannot put it on Zoom anymore, apparently.
Sorry, I didn't.
Yeah. So there is the link to the spreadsheet, and it will tell you which room you're in and who you're supposed to be with.
I think I didn't get an invite to.
Oh, okay, so if you didn't get an invite, you can probably complain about it and be added to a room.
You could join, for example, Sol Iota, or which room were you in a room last time?
Luna.
Okay, so if you were in Luna, I would join Luna Wilco.
Yeah, Luna Wilco, yeah.
Okay.
Thank you.
So I guess I was among the latest.
I was also kicked out.
Yeah.
Yes. We had a nice discussion, but we were not allowed to proceed.
No, we are not allowed. It's a future in which you're not allowed to have discussion.
And we wanted to play more, yeah?
Yeah.
It's better than radio silence.
All right. Let me share my screen. Okay, so we're...
Well, it was 40 minutes. Yeah, okay.
Yeah, that was 40 minutes. I'm pretty sure we were not the only group to not manage to do everything that we are supposed to do. So we basically did the first part.
Yes.
I saw that some people started to refine, which is good, like update the decks, etc. We didn't really have time to do that. But still, I think what we want to hear perhaps is very briefly some kind of reflection from each group. So we had more groups than we expected. We are way too popular as a workshop. So I think we had 7 groups. And if we want to do that within 15 minutes, that's like 2 minutes each. So I don't know if that's something that is feasible, but we could try.
Well, I think I could be pretty quick.
Yeah.
Speak for our group. Essentially, I think we didn't really get to this, play test, like discussing it and changing the cards. And I think we should have. That was actually an important thing to do. That the cards were there were odd crossover, so that we could end up with combinations that were kind of almost at odds with themselves or almost duplicating themselves. So yeah, the crossovers were kind of interesting and challenging, made it harder for actually sketching, I think, that we would end up with, I don't know. Yeah, I think that actually having got to the point where we were reflecting and changing our cards would have been a really good thing to have done.
Okay. So Jason had a question about, can we screen share for reports? That would be good, but I don't have the power to allow that. So maybe what's the best way to do that?
Can people add them to the Google Drive?
Like I've managed to share.
Oh, you're so strong. Go ahead.
Yeah. Thanks, Tech. So just very quickly, so we had 3 seemingly contradictory cards that we thought were incompatible. What do you watch from your catalog of media? It's personal data, and you're at a trailhead at the edge of the wilderness. And we just thought that wasn't going to come up with anything. And we were quite surprised that when we thought about it for 2 minutes, we did come up with things like a podcast that's based on your heart rate, which you select according to which trail path you go on. A movie that shows up according to where you are, that's relevant to your locality. and your photo selection being superimposed with some kind of augmented reality to show environmental change since your last visit. And we were all quite pleased with those. And I think another headline is that we just thought it was really interesting, and I certainly met some nice people, and those are very, very good things that shouldn't be undervalued.
Yes, that's true. I mean, yes. I mean, I think it was really interesting, and I also agree that things that seemed impossible, people did come up with ideas that were delightful and surprising.
What from other groups?
We were in a small group, but I have to say, I think the activity of generating the cards in itself forced you to think about things very differently. We had 3 really different perspectives, and that was hugely valuable and interesting before we even got to the sketching.
Free to jump in and just contribute to the discussion, right?
I wanted to add, so in ours, we had a little discussion at the end about abstraction versus concreteness and what makes for good pairings. And I think we found, every time we picked 4 cards, and in a number of those cases, there was I think probably what Sheila's alluding to, there's a bit of a weird over-constraint problem where the intersections of those cards don't necessarily leave you a lot of space. And I think we were tending to think that it's more interesting to have some cards that are a bit more abstract, specifically paired with cards that are more specific, and maybe focusing on smaller numbers of cards to do that.
The smaller numbers is interesting.
I'd be really curious to know if other folks had particular combinations of types of decks, for example, that worked really well.
We had, our first set had 4 cards that matched each other, and we all came up with a very similar idea, different but same combination of ideas, whereas the rest of the combinations were a bit more absurd. And 2 or 3 of us came up with a similar kind of idea. Some sort of went on a tangent, and they used one of the cards sort of like a metaphor and went to completely different direction, and that worked well as well. But I think if the cards are matching, it's probably quite obvious. Well, I guess it depends on the cards, but the combination was quite similar for all 4 of us, and that was with 4 cards. Every time we try that with 4 cards.
I think I want to second that from our group. We had one time where it was just, we more or less did the same thing, and then the other tryouts we got some really absurd combinations that was a bit hard to work with. And we also had 4 cards every time. So I'd be curious to try out this, maybe just 2 or 3 cards.
We tried with 3, and actually we didn't find it very easy. So we had one round with 3. And one of the things we discussed is, because I think we face similar challenges sometimes, was perhaps to give some freedom. I'll change a bit the rules so that the dealer can play a bit with what they draw. And so it could be, for example, that there is a wild card, something like that, or you draw 5 cards, and as a dealer you remove 1, or something like that. Or it could be each person, you have 5 cards, but each person selects 4 out of the 5 that they will use, to give a bit of flexibility when we have this kind of situation. But we also found that in some cases it worked very well, and we felt that it was being very creative, and we wanted to continue on. So having this option to have build-up rounds where you kind of build up on the previous round by, for example, selecting one idea and everybody rebuilds around this one, or by keeping 3 cards out of the 4 and replacing just 1, so that people can keep building on the same idea, but just with one factor that changes.
I think it would be interesting to do the non-random, that you see a whole deck of cards and just pick 3 you like. But you could sort of, in leafing through them, you could see all kinds of things that were like really intriguing, right? And that you didn't get an opportunity to play with.
I don't know how it was intended, but I think
when I was dealer, I kind of tried to pick categories that I liked and where I could imagine that stuff can work. So I think everybody did that in our group like this kind of, and I think that was quite useful because then you don't come up with these maybe contradictory constraints, I guess. So we just picked a category, someone else set a random number, and then it was still kind of random.
I think you could get around the problem of over specificity by having the two different types of decks where you have maybe 3 decks that are very abstract, but 1 deck that's very specific, so that you don't have quite so much convergence. We had the same thing where a couple of times we came up with very, very similar ideas because it was just so constrained.
I also think about, in terms of the right number of cards, that data viz is sort of one of our constraints to begin with, right, as compared to the future things original game. So maybe, maybe 3 cards plus the general constraint of data viz is actually the right number.
Samuel?
Yeah, for me, we didn't have the time to discuss about the cards themselves, but I was trying also to avoid conflict between when I was the dealer. But one of the things that I was really frustrated with was the time constraint, because my feeling was the first idea I had the time to find was not the most interesting one. So I wanted to iterate on this constraint and try to look at other ideas. And I didn't have the time. So the only time at one point I had the time to generate 2 ideas, but the last one was really like a really follow up on the first. And to me, this 2-minute constraint is really difficult. And maybe I like this idea from Charles about like trying to build on previous idea, because then you have maybe more time to explore a broader scope in the design space of this constraint.
Sarah?
Yeah, first I want to preface that our group took like a really objective approach to picking cards because we used a random number generator to like pick the deck and then the card. So we got really bizarre combos. And at first I always thought like, this is like crazy. And then a second later, I'm like, okay, it's actually kind of nice to deal with that problem that you don't already see an answer to when you're presented with it. But I think one of the things that we discussed was like the application of the cards, like, some of these things, like maybe it's just an icebreaker and it doesn't matter how wild it is, right? And it's actually just about loosening you up. Whereas other ones you could see really as being prompts that could be helpful for like a design process that you actually know the data, you actually know who, where, what you're designing for. Whereas other ones, like maybe they work in that context, but only in like AR or VR experiences, like having superpowers or something. Yeah, that's what I wanted to say.
I wanted to ask, just encourage folks to reflect a little bit on the degree to which things they designed ended up actually being visualizations versus applications. I'm curious how many folks ended up creating things that actually weren't visualizations at all, and if there are ways of maybe steering this in a more viz-centric direction.
What I think in our group we were kind of like half and half. We did have quite a few visualization ideas, but we were talking a bit about trying to think, how could this be visualization? But I think that, and I thought that even when we were generating the cards, but I think that choosing what the card deck titles are, that the kinds of things we were putting generally for card deck titles are more application kinds of things. I actually think you could think about what would be a visualization set.
What do you mean by designing a visualization?
Me or Wesley?
Yeah, I think it's an interesting question. So there's multiple levels that I'm interested in here. One is the thing you were designing actually a visual representation of something at all, or are you designing it an application or an interaction? And then the next level is, to what extent are you actually encoding some data in your sketch? I think that that's probably much more rare, but is interesting to try to encourage, because otherwise many of our visualization designs are really the idea of a visualization and not a visualization itself. So I'm personally really interested in thinking about how you could encourage people to design things that really play with some of the challenges inherent in a visualization, where you need to actually pick encodings that work with your data, which is hard if you don't have data.
Yes.
I think go ahead, sorry.
I think that it is hard if you don't have data. And we did in our deck actually even put one of our sets as being data, but even then it was we were picking sort of data areas rather than actual data. I think that one could think about what you needed as prompts if you really wanted the output to be viz. The other thing is, I actually think we as a community need to be a little gentler with ourselves. Okay, Jason wants to make a comment about that. Actually, data to visual mappings are non-trivial, and that will be enough. Jason, you wanted to make a comment?
Yeah, I can't put my hand up because they made me a host, so that's kind of weird. But no, this is phenomenally interesting, right? And I may have missed something at the start, but it kind of depends what you're trying to do. So just to stimulate a bit of creativity and a bit of creative thinking, that was a really good exercise. But one of the comments I made was that it's like a 100-meter sprint. If you stumble out of the blocks, you're not going to win the gold medal. So I started doing something really dumb for about 15 seconds, and there was no coming back. So you've got to be able to, do it a few times. But yeah, this thing about, are you trying to produce a visualization, or are you trying to solve a problem? That needs a bit of thinking, because I think both of those are really useful things to do, but some of our cards really pushed us in one direction rather than the other. So, I think if we'd spent a bit more time thinking about what our cards were intending to achieve, we could have probably done a lot better. But, one thing I really like what Charles was saying about, you've almost got to then go ahead and pick. I think actually you suggested we do this, we just didn't have enough time. You pick one that you like and you think, well, okay, that's actually an idea, and I'm going to go with that and do something else with it. And I think that's the way to go. We're sort of at phase one, aren't we? And yeah, I think there's what would be interesting is what really comes next, I suppose.
I think the other thing about saying, do you already have the data, is someone earlier made the comment that visualization is also about getting data. Particularly, it might be the canvas on which data gets collected, and it's actually an essential part of the collecting and representing data, not just about taking data that somehow you're given. And to do that, you sort of have to think of the back of a functionality that says, what are the kinds of things that we're trying to get, as opposed to, it's part of that conversation. I think I will echo what everybody else said, in that we didn't necessarily have enough time, but workshops are really problematic because you never have enough time.
Yeah.
And by the time you have enough time, you're so exhausted that you sort of fall off the edge of the cliff anyway. So this is obviously a brain kicker rather than a problem resolution. But I would encourage us to not go down the rabbit hole of thinking that visualization is only at the representation side of things. It's also about that entire conversation. But of course, it isn't about, are we trying to design the next Photoshop? It's really about what's the context in which this happens.
I wanted to, so the original method is about, if I understand correctly, thinking of prototypes, so thinking of objects, and so translating it into thinking of data visualizations. I think we sort of miss the aspect of data visualization where you have sort of an author, if you want, or someone coming up with the visualization and an intended audience. And so if we think of this exercise, we would separate between the context, like decks relating to the person coming up with the visualization, or having the data, or thinking of how it's going to be designed. And on the other side, decks for where it's going to be used. I think it could be a way of opening up things, because I noticed that because we had like some of the most fun decks were about context, and they sort of pushed us maybe in a direction of thinking about augmented reality or things like that. So I think if we separate these two things of you know, where it's used, how it's used by whom, and on the other side, who comes up with, you know, how is it designed? Maybe it's, you know, you can put like, get the tension in between the two, because there's definitely a tension there. I don't know if that makes sense.
I wanted to say something regarding Wesley's comment about that it's hard to encode actual data in these sketches. I thought about like, usually I guess when you create a visualization, you first analyze the data until you find something interesting that you then encode and visualize. I was thinking maybe including kind of a category or including into those categories kind of findings. So maybe there could be some categories about findings. I'm not sure how high level these have to be, but something like there's an outlier or I don't know, like these kind of things that could maybe be mapped to any kind of context and domain. And then this could be another kind of dimension that you can add as a card deck to it. And it might help to kind of think about some data that you want to visualize.
Yeah, we actually in my group originally had started to put together a deck that had a little bit of that flavor. And that's a route that I think would be really interesting to go down further. We had a couple of like data set with large outliers or bimodally distributed data set or data set that's distributed by geographically by population. And I wonder if there are other interesting prompts of that flavor that could at least nudge some ideas into a space where you get a bit more specific encoding that happens.
Also, it was interesting regarding what Lamia said about author and audience. So in our round, we actually had one category author, and we all kind of struggled with it. Like we had like an example where author was a scholar, and to us, like at least personally, like for me personally, it was hard to think about what would be the difference who makes this visualization. Like does it actually matter if it was a scholar or if it was someone else, or like isn't it more like the audience? I can totally see how important that is, but I didn't quite see why a scholar would be a difference to something else.
Follow up on the data distribution. We got a round where we got a data distribution card with a normal distribution, and I had really hard time to imagine anything else than a normal distribution curve. It was really difficult for me to just go away from that, and I couldn't, basically.
If only you'd been asked to do an audio representation, you would have sung a normal distribution, and that would have made us all very happy.
It was interesting. I think in one of the rounds, our group got fixated by one of the cards, and we all did the same thing. And then we said, look, if we realize that we've done that, then the next time we won't do it. And I think next time we started to use the cards a bit differently, to think how they can be not used in sequence, but used differently. So I think perhaps you change your own behaviors of how you use these inspirational cards.
Yeah, I think that's a really good comment, because actually there is many way we can read the sequence of card, right? Because it's not predefined inside the instruction right now. So I think the last distribution was basically flying in couple, energizing dynamic physicalization. And I take that literally as a sentence. And because it could work more or less like, but so I think the way we read the card or the way we give instruction to read the card will really impact the generative process. Maybe we can give many different instructions on how to read the card.
I've got to say, it reminded me of this thing that comes from like these people from Google called design sprints. I don't know if anyone's heard of them, but like one of the methods in like the sketch section is called this thing called Crazy Eights, and the idea is basically that in each minute you do a different idea, and that idea could work with like the cards so that you come up with more than one idea and explore it, but also still within a confined amount of time. So you still only have like 8 minutes to come up with 8 different ideas, but then you get loads down within like a small amount of time. It could be a way of solving that, maybe.
Maybe one deck should be how to use the deck. Like how to, use Crazy Eights or something else.
Kind of reminds me of the game Flex, where the rules themselves are up to interpretation.
I also think like Mad Libs, like that thing from the future is sort of Mad Libsy as it is, but maybe adding more structure might help with making it, like tuning it to be a visualization.
The points that we are starting to raise are about, what is the expected output of playing the game, or and if we do a design sprint compared to what we played, compared to other variations building on things, etc., the final result will be very likely very different, right? And so I think it's a good time, and because it's also time, to bring the last slide that we had, which is about the kind of general discussion that talks a bit about, if I manage to share my screen. Yeah. So there is really just one slide, which is, we were thinking about this kind of design activity. Where could it be useful for? And it can be used in many different situations, for example, different contexts. Do you want to, is it a classroom exercise to learn about visualization? Is it a design exercise? Is it something that you do in a company or with clients? Is it something you do to brainstorm about research? I don't know. It can be many different things, and based on that, the rules might be a bit different. But also, we wanted to talk about kind of opportunities and challenges with this kind of method. Is it a good idea at all, this kind of thing, and in which direction can it go? And we can talk about next steps after that. We had a few topics of discussion, but I think it's good to just, for now at least, just keep you talking about things that where you would see that going, for example. I just lost.
I have more a question than a comment. Which one of you has tried this in class before? I would really like to get a little bit more detail on how you tried it, how long it took, how you used the results.
We have not. So
okay.
But that's something we would like to try if we manage to create one set of decks that would kind of make sense and keep trying it in the classroom. But it would have a specific purpose here at that point, right? And depending on what kind of outcome you want the students to learn from this activity, which might alter the way you design the slide deck.
That's good. That's kind of what I've been thinking, is that yes, one could perhaps design a slide deck for a particular learning outcome, and that in itself, thinking about how to design given decks for different purposes I mean, these are very analogous to the IDEO cards, but the IDEO cards are really designed for coming up with applications. Like Wes said, how many of you were actually designing VIS and how many were designing applications? And I'm not sure how much of the intent about that carries over into this. So I would say that the actual ideas that we came up with in our group were at least 50% VIS and maybe higher.
I mean, in the Interactions Lab at Calgary, we've used this format or in this type of exercise to do a couple of things. Wes has taught a Interacting with the Futures class where the intent of the course is to get students thinking about future, sort of longer term futures, if just to have some sense of if their research is successful, what's the 20-year vision of where that would go. So teaching futuring almost as a research skill. The other thing we've done more recently has been to use this sort of format to think through things like what is the future of the lab going to be in terms of what's the future of research or academic life going to look like in different sort of minute details, and thinking around it in terms of concrete artifacts or rituals as opposed to, you know, kind of thinking about things more vaguely. It's so somehow the idea of grounding in a specific artifact or design has been helpful in wrapping your head around what that future means, or well, what that future means to the people who are doing the designing. So oftentimes it's much more reflective of the people who are doing the designing than it is of any their vision of the future than it is a specific vision that, you know, should be more concretely. Because yeah, the audience for this game in itself has a huge impact on what you do with the results. Yeah.
Yeah, I guess my challenge is that my students, they always think of bar charts and Python notebooks, and that's about it, right? So I'm trying to find something where I can engage them to think more broadly about something they could be doing for a class project. So I imagine this could be quite fun as a first steps, like, hey, you have to do a project, but it doesn't have to be a Python notebook with bar charts in it. So yeah, it would be fun to try, I think.
Yeah.
I was thinking this might be very good for, you know, working in the application space. A lot of times when you work with somebody who has a particular domain, they have their data. They don't really know that much about visualization. They already have some tools and methods that they use, but they don't know what else is out there. So just creating a little looser environment where they can see other options and, you know, start to think that there are different ways of representing data and different ways of, you know, thinking about their problem even, I think could be a very nice application for this.
Yeah, I think they actually, relevant to what both Petra and Bernice said, and hi Bernice, by the way, and hi Petra, is that it's a very good way of breaking mindsets, I think.
Yeah.
I've used not the game, but a kind of a similar IDEO card kind of thing approach, especially when I'm doing external training and you get people who are very locked in a particular mindset. And it's a way of making them break it. And what I liked about this, let's assume that the question about whether you were designing or an application or not was actually not a bad one. Because what it says is, what do you need to think about when designing visualization in the service of something? And that question of in the service of something, I think, made people just step out of a comfort zone. So anytime we've got people to get stuck in a comfort zone, this is probably a good way to rattle the cage.
Mm-hmm.
I can add
Yeah,
from
oh, sorry, go ahead, Richard.
I was just going to add from a non-academic perspective in industry, having these methods can be extremely useful because it can be really easy to generate maybe 1 or 2 or 3 design ideas, largely based on, say, visualization best practices, but it's easy to get locked in. And having techniques that get you outside of that locked in environment becomes really important. And in industry, it's even more important because you might not have access to a whole visualization lab, for example. And so having these externalized aids becomes really useful.
Yeah, so that's a great point. And I think like just having a card you flip that says now break something you just put some effort into making is quite a nice card, because you get to these local minima, you know, and you've put so much effort into the beautiful comment card that you just created that you want to keep using, you know, but sometimes just throwing those things away is a really important part of design. But the thing I was really going to say is that I think this kind of, it reminds me a bit of some of the creativity stuff we did before. The whole visualization analogies, creative thinking thing was a bit like this. And that, you know, we would put visualization examples in front of people, and as I'm sure many people do, and get folks to try and transfer those ideas to problems they're working on. But that just makes me think, well, why don't we have cards that have got visualization or visual prompts, you know, as well as text-based prompts? I don't know whether anybody's done any of that. You could have shapes, and they might be kind of organic shapes from nature, or they might be shapes from VIS, or they might be, you know, it could be anything, but having visual stimuli that you need to incorporate into your designs could be useful. And I think that's the way I work. I think I use shapes and patterns that I see about the place and try and use them to stimulate design ideas, really. That's where some of the nice ideas come from. I'm going to go and pick that up again because I liked it.
Yeah. I mean, I think that some of our slides were very text-based and a few were visual. But I'm not sure. We actually ended up with a moderately high number of visual slides, but I think we focused more on the words when we were thinking about designing than on the images, which is interesting and counterintuitive for me. But maybe it was even part because we couldn't put them out in front of us, so we just had a bunch of words like for memory points of which cards we were thinking about. Whereas if you were actually doing this in the physical world, you would have the images. And I thought that like taking a little bit more time, and people who had bothered to make slides with images on to actually have the images put across my screen would have been quite a different type of prompt, and could have been nice to try.
So I wanted to jump in, since we only have about 15 minutes left, and just maybe see if we could broaden the conversation a bit. We focused a lot on this particular featuring method, and I wanted to just see if people had any thoughts on the idea of featuring methods for VIS more broadly. So not just these kinds of really quick ideation exercises, but also things like, you know, featuring videos and artifacts in the future, and where we see opportunities for that kind of featuring in this space and in this community.
Well, if I would love to see more papers that are design fiction paper or vision paper in VIS. I really would like to see that more, but I think it's really difficult to publish this type of paper. Actually, there is not too many. I think there is many example of vision paper in CHI. I'm not sure there is many example of vision paper at VIS.
It's interesting how different communities have, like, yes, because we have certain types of papers that we have quite a few of, like sort of methodology / guideline papers we have quite a few of, and now we actually have quite a few of the you know, meta reviews of literature type papers, but we don't have very much of featuring papers.
I still find it surprising that we don't have pictorials.
Yes.
Yeah. That would be amazing to have a, well, there is pictorial at VISAP, but there is another thing. So I tried to do an exercise with my student about visualization and the future, which is a bit really different from that one. It's basically, it's a one week activity where I ask my student to explore what they think the future will be in the next 50 or 100 years based on fiction or scientific fact. And they have to build a visualization, a forecast visualization, with where the visualization encompasses all the scenario together in the same time. And that's another type of activity relative to future and visualization, which is on a really different scale. But one of the reason I want, one of the things that I like, it's at the beginning there is this tension between, we had this tension about I think so. You mentioned near future laboratory at the beginning of your talk, and there is one of the founder of near future laboratory, Nicolas Nova, wrote a book in French which is called The Failure of the Imaginary, and inside this book he's speaking about all the visions that people are bringing into technology and HEI. He did a PhD in HEI, and he's saying like most of the time it's always the same type of vision. It's really limited in a way, and he says he's really frustrated about this limitation, and he's giving him a lot of example like flying car, a connected kitchen, and all of these type of examples that are. And in a way, it's kind of critique, but also it's, I think he's inside this book is locked inside the subspace of what could be the future. But I think we are also a little bit locked in. So I think we should find other spaces.
I gave a couple of years ago, gave my students an exercise that I said, okay, think about something that might happen in the future. And then what I want you to do is to build a visualization of the side effects, the knock-on impacts. So, and the reason I remember this is, this was a flying car example. So one guy was thinking about flying cars, and then he started to think about what would it look like to have an infrastructure that supported that for the people that had to deal with it, if you were the driver or if you were the, so started to think about what would you need to know. And it only happened because it turned out that we were supposed to have a guest speaker and the speaker didn't show up. And so I had this empty space. I didn't know what to do.
Yes, nothing like pressure to make you creative.
But the point is that I like about these kinds of exercises as well is that they force a kind of a thinking out. I think the point about the visual shapes and the prompts for this that Jason brought up is really important. But the general piece here as well is it makes people think about things slightly larger. And you start saying, many of us come from a human-centered design perspective where we're familiar with saying, not just who's an audience, but what are the implications of seeding it into the audience? But for many computer scientists, that's an unfamiliar question beyond the basic, oh, well, the user will be, you know, a white male with a salary of this level who's familiar with a phone kind of thing. So I like these activities, even at a very initial stage, because they force that kind of thinking. And so I think then the question is, how do you prompt it, as Jason and Sheila have said, to say, now think about what the actual implications are for the design of data viz.
As someone without a research background, I'm kind of curious how folks here think about this, this question of whether the obstacle is more one of imagination or technology or adoption or something else. And I think change probably happens, progress happens in fits and starts in this industry as much as any. So what are the, at any given time, what are the obstacles?
Well, to me, the obstacle is the relation between technology and imaginaries. One of the problem I find with this type of card deck is, do we think of every solution as a technology solution?
Yeah.
Yeah. So maybe we should talk about where next as individuals, where next as a group, what we would like to see come out of this. I mean, I think that the whole experience has personally been rich and given me all kinds of things to think about, but I'm wondering if people want to discuss where next.
Yeah, I wanted to say, I personally, at least, I think I'm very interested in continuing discussions around this on a number of fronts. We have a lot of really great just initial brainstorms for card decks that we generated over the course of the last few hours. If there are people who are interested in continuing to maybe push ahead on that and try to construct something that's a bit more usable as a pedagogical tool, something that those of us who are teaching could use in our classes or could use in brainstorming sessions with clients, I would definitely be interested in working with some folks to go ahead and evolve this a little bit more into something that's a bit easier to use in some of those settings. And I love the idea of even at some point maybe going all the way to physical card decks. I've been using John Swabish's graphic continuum cards in my classes a bit in the last year or two, and I find those really compelling. Like actually having an artifact that's dedicated to this that you can use in a class is really cool, and I think also makes it feel a little bit more like a real thing to students. So if there are folks who are interested in doing that, it would be fun to continue and maybe even mine what we generated in the last couple of hours as a starting point. More generally, I think I am really curious about pushing for some more vision-oriented things at VIS. The idea, so WIST for the last couple of years has actually done a couple of vision talks in the evenings, and I found those really compelling. And I wonder about, maybe we think about nudging VIS to try to introduce something like that in the next couple of years, or think about the potential for doing pictorials in this space.
Yeah, because pictorials would lend itself well to the space, because you can't really say, okay, you have to make it if it's for the future. You want to use things that are not necessarily feasible yet, right? For situations that are not necessarily present yet. But yeah, pictorials might work well.
Then.
Thanks. I think there are at least 3 associate editors of transactions in visualization and computer graphics on the call, counting around. And maybe those folks ought to put a bit of pressure on the editor to be a bit less conservative about the nature of the publications that are being published in the journal.
That would be, yeah.
And I want to quickly bounce back on what Wes was saying about using this idea of a card game as a starting point to explore a bit more in that space, and in particular in the context of teaching. I think a lot of us are art teaching, and although we might not be able to use physical cards these days, it might take a few years, but one day we'll be able to. At that point, we can have card games. I would like to know how people feel about how can we kind of collect information about people who would be interested in that, so that we can synchronize a bit and keep building on that, and perhaps do some iterations in the classrooms and report back, etc. So we don't have an email address for the workshop. I don't know what's the best way to just create
Yeah, I would be interested in trying to see if we can figure out how to tip a card deck so that most of the ideas that it triggered were in the visualization space. And what that would mean, and how one would change that. Also would be interested in trying to find out for particular challenges that students are having, how can one tip a card deck to help learn a particular problem? Like, I think that card decks can be more focused than we have been thinking at this point. And that would be interesting to explore.
I think we actually had an interesting one in the Wilco group where people had made a deck called Display Medium that had things like paper, devices, overhead, physicalization, sonification, tactile. And so you could imagine having some constrained decks that you would need to choose 1 or 2 constrained decks in addition to these more freeform decks.
Yeah, maybe. Maybe.
I also really liked, we had this deck that was books that really, I think for many of us in the group, evoked this idea of thinking about, okay, what would a visualization inspired by like religious texts, what would that be? How would that look? How would that behave? Or inspired by, what was some of the other, there was manual, there was poetry. There was science fiction and so on. So thinking about these, not so obviously if you got science fiction, you could take that as thinking far into the future, but you could also think about maybe from a visual point of view, how would something that looks science fiction, how would that look, or how would that behave? And there was another one where plays could either be interpreted as use context, but it could also be interpreted as, okay, if you got the play's forest, then could you somehow get inspired from how a forest looks or how it behaves to think about how can your visualization look or behave. At least to me, those were kind of inspiring. We never got to choose from that deck because we were in this stupid random group. But yeah, I'd be curious to try that out and see how that would actually influence how a visualization might be designed.
So Cheryl, we're at the end of our slot, right? I wonder if it's worth it, especially for the very specific exercise of going ahead with these decks, to maybe collect names and emails from folks who might be interested. Because of the way these workshops are operating, we don't necessarily have a list of attendees. And I think it would be useful to collect names of folks who are interested in maybe participating in continuing to flesh this out, or even just play testing or using them in the future in classes or other settings.
So I just shared this link to a Google Doc. I don't know how people feel about writing their email on a Google Doc. I don't have a problem with that. But where we could, have a few categories of things that we would be interested in. So I added one header about this card deck for in-class exercises that we talked about, but there could be other directions that people would like to pursue, and then we can also kind of indicate that we are interested. It's clear that these kind of workshops, it's easy to just have them disappear and we forget about everything. It's one way. I don't know if there is another way that people want to think about, to go forward, to keep in touch, and to communicate who are involved. We could create a Slack group at a point, etc. But I think having this initial list of emails will be helpful for that.
So everybody has yours, Wes, Laura's, and mine as the organizers, right? So people could, if they don't want to put it in the Google Doc, they could just tell us.
Yeah.
Oh, actually, that's a really good idea, Jason. Have a Dutch stool on it. On visualization futures.
Yeah, remote Dutch stool.
That would be cool. Yeah, assuming that we can get back to having jug stools. Exactly. I wonder when. Exactly.
I do think though that the specific objective of building decks is it's quite manageable. I like activities that involve an output, and we've got some draft decks here, so there could be another revision, like the kind of thing you hope to do in the time but we didn't quite have time for. Yeah. I think that would be a good exercise. And one of the things we've discovered is why we don't have to do this at VIS. We don't have to wait around. We know how Zoom works. Okay, we just need to find times in diaries. I mean, it's kind of interesting to. Well, does anyone dare have a follow-up workshop that isn't during this week and that isn't based upon permission from IEEE VIS? Because
yeah, we could do that. Well, that could totally happen because I mean, like somebody just said, there's Dijkstoel and there's Banff/Beurs, and there's also Banfield, which is hungry for people to run workshops, and is even more remote than any of these. I would love to do a Banfield thing. But right now, getting there, it's just not going to be possible until we get into the other side of our current global crisis. But doing these, in fact, actually, that's interesting in itself. Actually thinking about doing ideation on distributed, face-to-face distributed work like this is interesting in itself to me. I mean, I think it's our new current challenge. Yes. Banfield is amazing, and Calgary. So our universities plus UBC have this station out on the west coast of Vancouver Island. It's a little bit more rustic than Banff, but it's actually really cool and just like stunningly amazing place.
Sam, did you have one last thought?
Yeah, just as something that could be actionable if we are all teaching online, one of the things that could be interesting is to try that online, but with students from different places over the world, because one of my experiences only by mixing students from various curriculum, I see sometimes some really interesting things happening, and having some people from different places may happen.
A great idea, because that was something that I used to sort of culture a lot in iLab, that we had people from all over the world as part of the lab, and that I've been kind of thinking, oh, we can't do that, but why not? Why not do it like this? I think it's great for people to meet each other from different places.
Yeah. So I think the Zoom closes, what, 10 minutes after? There is a hard cutoff at a point, and the Zoom just disappears. So we are going to be
getting close to it.
But I think one easy step would be for us to probably create a Slack group and start discussing these different ideas. I'm going to teach visualization in January, and for sure I'm going to try something like that. It will be virtual, but the same kind of games that we have been playing here. And I think there is a good way, based on the audience of your different students, to try different types of decks to see the kind of prompts that they need, and based on what you want them to learn, if it's about generating crazy ideas beyond the bar chart or the pie chart, like Petra was saying, or if it's about things to do variations over a theme, etc. I think there are many ways to be creative there in the kind of decks we create, and based on that, perhaps have several decks to draw from based on the activity you would do, from pedagogical perspective at least.
Yep.
Yeah, I think if you want to send one of us an email, put your name in the Google Docs list. Let's definitely find some more opportunities to connect around this. These conversations were a lot of fun, and I would love to keep having an excuse to think about this with some biz folks.
Yep, Kelly.
Excellent.
Yeah. Yeah, thanks a lot for joining. I had fun. I could train my sketching skills, which are pretty terrible these days. I think this was very interesting, and there is a lot of directions that I can see forward based on what we talked about today.
Yeah, I may even try and do something, because I'm teaching Viz right this semester, to see if I can do something in the next few weeks.
I have the final slide.
Cool.
Taylor-Coyer flows is a turbulent fluid motion created in the gap between the two rotating cylinders. The traditional reason-based methods are only able to capture the small-scale coherent structure. The detection of the large structure depends on the 2D cross-section, which is not the true configuration. We adapt the feature level set methods and the density estimation to combine multiple attributes and use them as the filter to separate large and small-scale structure.
Confusion flow is an interactive visualization for the performance analysis of classification models. It introduces a novel temporal adaptation of the confusion matrix, which lets model developers compare the learning behavior of multiple classifiers over time. Find out more about confusion flow in our talk or in our TVCG paper.
How do you visualize the nanoscale, 1/1000th of a meter for the public?
As part of a Science Center exhibition, we developed an immersive environment that explains nanoconcepts by allowing users to explore nanoproperties. We reflect on how exploration, the confluence of explanatory and exploratory visualization, can be applied to visualization in public spaces.
Digital humanities present great opportunities for testing new visualization approaches and evaluation techniques. However, and given the diffuse character and novelty of the field, it may also be intimidating for novel and senior researchers willing to get started in the discipline. In this paper, we propose a data-driven analysis of visualization for the digital humanities to identify key themes, authors, and relevant publications. So if you want to know more, please read our paper.
A testing environment for continuous color maps. Many other fields in the computer science do it, we should do it too. With our work, we introduce the approach of using test functions as a standard evaluation method. We present a test suite for continuous color maps implemented in the CCC tool. Adapt the task to your requirements at the interactive testing section and observe them at the testing evaluation section.
In our current work, we visually compare two cohorts of segmented and classified tissue images, originated from single-cell omics data. To that end, we developed data-driven and interactive workflow implemented in a multi-linked view system. Finally, we show the effectiveness of our workflow through specific case studies.
Scatter plots and parallel coordinates are widely used for visualizing multivariate discrete data. However, for multivariate continuous data, the continuous scatter plots and continuous parallel coordinates are more suitable. In this work, we extend them to uncertain data. Additionally, we also extend fibers to uncertain data. If you are interested, come to our presentation.
We present the first generic design space and library for visual piling. Inspired by physically piling paper documents, visual piling describes an interface for spatial organization of visual artifacts into piles of partially overlapping items. Piling affords interactive grouping, arrangement, previewing, browsing, and aggregation to reduce the complexity and support comparison of large collections of small multiples.
Deep neural networks are vulnerable to maliciously generated adversarial examples. This brings high risk in applying these networks to safety-critical applications. We developed a visual analytics approach to explain the root cause of such wrong predictions. Our contribution contains a constrained path extraction method, a river-based visualization, and a contribution analysis method.
CMed is a visual analytics framework for exploring medical image data annotations acquired from crowdsourcing. CMed can be used to visualize, classify, and filter crowdsourced clinical data based on a number of different metrics such as detection rate, logged events, and clustering of the annotations. CMed provides several interactive linked visualization components to analyze the crowd annotation results for a particular video and the associated workers.
Several recent studies advocated the use of non-parametric density models for the improved characterization of data uncertainty. The non-parametric models, however, present the challenges such as increased memory and computational requirements. In this work, we propose an efficient non-parametric framework for volume rendering in the context of uncertain data and show their effectiveness in classifications via comparisons with the other statistical models. Morse complexes have shown a great utility in understanding the topology of complex scientific datasets. The noise in the scalar field, however, can significantly distort the Morse complex topology. Hence, we study the extraction of Morse complexes for ensembles of noisy scalar fields through their uncertainty visualization using our proposed statistical summary maps.
Asteroids have always been and will always be a threat to life on Earth. Most likely, an asteroid will hit deep water, but what properties will actually lead to a threat like a tsunami? Ensemble simulations are a common tool to understand the effect of different parameters like the size of the asteroid. We propose an interactive visual approach to help analyzing deepwater asteroid impact simulation ensembles.
We present TransVis, a design study that is proposed to analyze and integrate close and distant reading of multiple translations. TransVis presents the overview of the collection to capture global patterns that is facilitated by the ADM-VIV matrix. TransVis integrates a detailed view to explore interesting path of alignments. We also propose the TLC view to examine and explore the terms of the user selected path to justify and reason the AD analysis.
We have seen many visualizations for tree data structures, but when showing changes in trees over time, some focus on displaying hierarchy, while others highlight their changes. With split streams, we combine two approaches and their individual benefits. We evaluated our method in a user study and consider it a general-purpose method for the visualization of dynamic hierarchies. Our JavaScript library is openly available.
In this study, we designed a system named Causality Explorer to facilitate the causal analysis. Users can explore the causal graph to perceive the causality and its uncertainty, validate the causality with the raw data, and apply the confirmed causality to what-if analysis.
We asked participants to recreate bar graphs. When the bar was alone, we saw a different pattern of error than when the bar was presented with context in a stacked bar graph. We find that absolute error increased for higher bars when they were presented alone. We also found that there was a bias in the responses such that they were repulsed from an implicit 50% mark. We found a magic number, 10%, to predict error. Participants are usually within 10% of the height of the bar.